For any right-angled triangle, most of us have learned the SOHCAHTOA method of remembering the sine, the cos, and the tan ratios. So if we label our sides as opposite, adjacent, and hypotenuse, then the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tan is the opposite over the adjacent. Now, if we flip those or take the reciprocal of those ratios, then we also get what we call the three reciprocal ratios. For sine, if we flip that, we're going to get the cosecant ratio, and cosecant is hypotenuse over opposite. If we take the reciprocal of cosine, we're going to get the secant ratio. That's 1 over cos, or h over a. And if we flip the tan or take the reciprocal of the tan, we're going to get the cotan, which is 1 over tan, or a over o. Another interesting relationship between these ratios is if we have a look at the sine and the cosine of theta, if we take the sine of theta and we divide that by the cosine of theta, then that means we're taking opposite over hypotenuse, and we're dividing that by adjacent over hypotenuse. So we're really dividing fractions here. When we divide fractions, what we do is we multiply by the reciprocal of the second fraction. So if we flip that bottom fraction upside down and we multiply, look what we get, O over A, which we know is tan of theta. And so tan of theta is equal to sine theta over cos theta. That one's called the quotient identity. So going back to our right-angled triangle, all right-angled triangles follow the Pythagorean relationship. Remember, a squared plus b squared equals c squared. So I've changed the letters a little bit to reflect the names of the sides in right-angled trig. We call them the opposite, the adjacent, and the hypotenuse. And I've got the Pythagorean relationship, o squared plus a squared equals h squared there. Now this is a kind of a neat little thing. If we take all of the terms in this equation and we divide each of them by h squared, so we're not changing the equation because we're doing the same thing to each term, but we're going to notice some patterns here. First of all, h squared divided by h squared is just 1 on the right-hand side. On the left-hand side, we have o over h, which is sine squared. So let's write that as sine theta squared. And then we have a over h, which is cosine, and that's squared also, so we have plus cosine squared theta. And on the right-hand side, we said that we had 1. What we've just done is we formed the most common of the three Pythagorean identities by simply taking the Pythagorean theorem relationship between the three sides and dividing them all by h squared. If we start over, and instead of dividing everything by h squared, this time let's go through and divide everything by o squared. So here we have o squared divided by o squared is 1, and a squared over o squared, that is the opposite, or the reciprocal, I should say, of the tan. And so here we have cotan. And when we have h over o, we know o over h is sine. So here we have the reciprocal for the sine ratio, which is cosecant. And so we have 1 plus cotan squared equals cosecant squared theta. That's the second of the Pythagorean identities. For the third Pythagorean identity, you probably guessed it already, we're going to divide everything in our Pythagorean equation by a squared. O over A is tan. So here we have tan squared. A squared divided by A squared is 1. And we have h squared over a squared. Well, we know that a over h would be cosine. And so this is the reciprocal identity secant. And so here we have secant squared of theta. So that gives us our third of the 3 Pythagorean trigonometric identities. The last 3 identities that we developed are the ones that you will use the most often, but there's several others that are going to come up, especially in first year and beyond calculus courses. So what I've done is I've listed them for you here, the most common identities. And this would be a handy thing for you to have, pinned up on your corkboard or whatever you use as a formula sheet these days. These formulas will come up quite a bit in the calculus course, and so it's a good idea to familiarize yourself with them. As always, whenever you need help with math in any course at Trent, you can contact me at mathhelp@trentu.ca for either online or in-person appointments.